All attendees are in listen-only mode.
Hello everyone. Hi. Uh, as usual, before we get started, any questions for me? All right. So I'm hoping that you are all comfortable with all the topics what we covered so far, right? So today we're gonna get into a crucial part of core Java framework. That is crucial part of Java SE training. That is collection framework. So I will let you know what exactly the collection framework is, but before we get into the collection framework, I would like to let you know how Java simplified things for us, with the help of collection framework. How Java simplified things for us with the help of collection framework. What I would like to do is, I would like to build my own data structure. Now what do you mean by data structure now here? So what is variable? It's variable is a name given to the memory location. Variable is a name given to the memory location. Oh, we are on to day 11. I'm creating a class. Alright now. Or let me create a normal file. So first, as we all know, what is variable? A name given to memory location. A name given to the memory location is called as variable. What is data type then? Data type decides what amount of memory and what amount of memory is being labeled, and what value one can store into variable. What value one can store into variable. The data type is going to decide this. Then what is data structure? Data structure decides how the values are arranged in the memory location. Mainly there are two types of data structures. You got your array and the linked list. And what is the difference between the array and linked list is memory locations of are one beside the another. Memory locations are one beside the another. When it comes to linked list, memory locations need not to be one beside the another. This is very important thing to understand. Now what exactly I mean, array memory locations are one beside the another, and whereas linked list memory locations are need not to be one beside the another. Yesterday I forwarded one reference with respect to, no, I'm sorry. Right, it was not for you guys. Let me open this MS Paint. Then I'm talking about array now. Yeah. So this is I'll let you know how the array looks like now. So this is how the memory location happens for array. The memory should be exactly one beside the another. They should be exactly one beside the another. So suppose if you assume that this completely is your memory location, if you complete that, this complete MS Paint screen is memory, and it needs some 100 bytes of memory, and this 100 bytes need to be contiguous. They need to be together, right? Suppose this is being used up. This is also being used up. Now I need some bytes of memory. I have sufficient space. I have here, I have here. But if it is array, I cannot allocate the memory. Now I have a space. See, this all, whatever the space here, this is being used up. This is being used up. But I have the rest of the memory. But if I want to allocate the memory for array, that need to be contiguous. The memory need to be one beside the another. If I want to allocate the memory for array, suppose if I want to allocate, suppose this shaded region, let it be some this pink color region is something 500 bytes, and the yellow color is something around 400 bytes, and I need some 800 bytes of memory for array. So when I need that 800 bytes of memory for array, I have 900 bytes left with me, but memory allocation will not happen because all 800 bytes are not being together. Not being together. They are not contiguous. That is a problem with the array. Whereas if you consider your linked list, yes, I have a 900 bytes of memory here, so the memory allocation happens because for linked list, they need not to be together, or the memory need not to be contiguous. The memory need not to be contiguous, right? So how this memory allocation happens? So I already demonstrated how the memory allocation happens for your array. So this is what the memory allocation. So when I say array of 0, first location, array of 1, second location, array of 2, third location, array of 3, fourth location, and array of n minus 1, the last location. This is what your array and how memory allocation happens. Whereas if you consider now linked list, that will be very interesting. We have a node and every node is divided into two parts. We have a node and every node is divided into two parts. So in total, how many nodes I have? I have almost 5 nodes. So what happens is the first node will consist of the data. Suppose it's storing the values. Then the node consists of two parts. The first part stores the data. What about your second part? Your second part will hold the address of the first part. The second part will hold the address of the first part. I'm sorry man. Right. A node consists of two parts. A node consists of two parts. This is referred as a node. This is referred as a node. It consists of two parts. Right. So we need to develop our own data type. We need to develop our own data type. How will we develop our own data type? How will we develop a node? Simple. Class node. Now within that, what you want to store? Integer value. So it's a data. So what it has to point to? It has to point to the next element. So the next element is of what type? Node type. So the next element should be of what type? Node type. So this is the class. Now what is this? This is another node. So I hope you guys can guess now what is happening. A node consists of two parts. The first part is holding the data. The second part is holding the address of the next node. Whereas in the array, you don't have that concept. So array memory locations are one beside the another. Whereas when it comes to linked list, they need not to be contiguous. The first element keeps the address of the second element. And second element keeps the address of the third element. And third element keeps the address of the fourth element. And fourth element keeps the address of the fifth element. And fifth element being the last element, it won't store any address, it keeps null. Fifth element being the address of the last, fifth element being the last element, it won't store any address, it keeps the value null. And this is how the memory allocation happens in linked list. But there is a problem. In array, they are one beside the another. So the way you access the data is very fast. In array, the elements are one beside the another. So the way you access the data is very fast. You can go there very quickly. Whereas in linked list, traveling across the data is very difficult. But memory wise, they are very, very good. Linked list, memory wise, they are good. But accessing wise, they are slow. Because if you want to reach the third element, you have to go to the first, then second and third, because they are not one beside the another. Whereas in the array, if you want to go to the third element, you can simply say array of 2. If you want to go to the fifth element, you can simply say array of 4. Whereas here in linked list, you cannot say that. If you want to reach the fifth element, you have to travel the first, second, third, fourth, then you reach the fifth element. So data accessing is very slow when it comes to linked list in comparison to your array. In array, the data accessing is very quick. But what is the drawback of array? It looks for a contiguous memory allocation. And what about your linked list? It doesn't look for contiguous memory allocation, because the first element keeps the address of the second, second keeps the address of the third, third keeps the address of the fourth, and the last element hold the null value. And every node is divided into two parts. One is the data part, other is the address part. Right. So already we discussed some programs on arrays. Alright, so what we did, we searched for a value in the array. So on array we did some programs. What are the programs we did? We search for an element in an array. Then you can also do a lot of stuff. You can take them as assignments to sort elements of an array. Find largest of array elements. Find second largest of array elements. Then you did sort elements of an array. That's fine. This is more than enough. Okay, let's do some more. These are the normal programs. Okay, now let me add a complicated or a different challenging programs. I don't say complicated. Implement a data structure called stack. Then I also say implement a data structure called queue. Right. So let's see what exactly you mean by a stack. Stack is, it's a container. You can say it's a one-mouthed container. One can add and remove elements from same end. In the sense, the last element should be the one to go out first. Now what do you mean by queue? Add from end and remove from first. So these are the data structures I want to develop myself. I want to develop. So let's develop one. Let me develop a class called stack. Alright, so what is stack? It's a one-mouthed container where we can add elements from one end. We can add and remove elements from the same end. So what is array? What is stack? Stack is a data structure. So your data structure can be an array or data structure can be a linked list. So I'm going with an array. And here I fix the size of it. I fix the size of this. Let it be 5. Right. Then, as we all know, in order to manipulate an array, what do we need? We need a integer variable. In order to manipulate an array, we need an integer variable. Let's say count, or you can say in stack terminology, we call it as a top. Let the top is -1, because when I say top 0, that indicates there is a first element in the stack. Because array count starts from where? Array count starts from 0. So if you are accessing 0, it means you already have an element. If you are accessing 0, indicates that you already have an element. So I am taking the top as a -1. Int top equal to what? It's -1. Right. So that indicates no elements. It's empty. Top equals -1. What that indicates? Indicates it is empty. Now what I would like to do, I would like to add some methods like public void push. Let's say push add an element. But I don't want to say void as my return type because the array size is restricted. If you look at this, there is one more difference between the array and the linked list. Array sizes need to be fixed. You cannot have your array dynamic. Array size cannot be dynamic. Whereas linked list size is dynamic. Linked list size is dynamic. Now why I don't want my return type to be void? Because if the size reaches 5, that is your top value reaches 5, then you won't be able to add an element. So I want to tell that element is added or not. I want to tell that whether the element is added or not. So you got a boolean and the method name is push and it got int data. So boolean, I'm just taking a variable inserted, which is false. Then I return inserted. So in between I need to do some logic. How will I do it? If I want to insert, first stack need to have some memory, or stack need to be, the space should be available. So I will check if top +1 is equals to 5 or not. If top +1 equals 5, what it indicates? It's full, then I return false. I return inserted. You can say, yeah, you don't need to do anything. If top +1 equal to 5, you can simply say return inserted. Because it already got a boolean value false. If the top +1 is not equal to 5, if top +1 is not equal to 5, then there is some memory available. Then what I would like to do is, I would like to store the value. Stack array, right? Then I would like to do it here is, you got ++ top, that is -1 ++ will make it 0. Then I would like to assign the data into it. So into the array of 0 you are storing the value. Then since the value is successfully stored, then you can change the value of the inserted to true, then I return it. And here, since already you have your boolean value, you can still say here inserted is false. Right, or you can just ignore it. You don't need to do anything. It returns false. So this is a push method. Then similarly you can have pop method. Your pop method is nothing but your delete. But understand here you won't be deleting whatever the element you want. The significance of stack is you only will be deleting the last entered element. So before you delete, first you need to check what is your top, or what is your top. If your top is still -1, then you have nothing to delete. You say return false. But in case if you have, if the top is equal to -1, it's empty. If the top is not -1, then it is not empty. So if it is not empty, you just need to do what is top minus minus, decrease your top. Decrease your top. And then just return true. That indicates the element has been deleted. Here also, instead of taking a Boolean variable, what you can do is you can simply say here return false, because you cannot accommodate the new element. Here return true, because you already accommodated the new element. You don't need this. So this is how you constructed your own stack, a data structure called stack, alright, which is of size 5, and you have a method to add data to the stack, and you have a method to remove data from the stack. Next, in case if I wanna display the elements, how do I do that? So right click source, getter and setter for stack array. No, I don't need a setter, I just need a getter, and getter for top. Now let me write a program called run the stack, but I won't be doing that menu driven program. I just say I'll just create an object for stack, then I'll be pushing some elements into it. So it will tell you whether stack dot push some data. I'll keep adding. I'll try to add more than 5 times so that you can see what happens when you cross the size. 33, 43, 45, 54, 67, 76, whatever you want, you can add it. So if you want to observe what is happening, you see true all the times. For 5 times you see true, then later on you'll keep seeing false. Later on you keep seeing false because you already reached your maximum threshold point. You already reached your maximum threshold point. Now, if you want to see, you added all the elements, and if you want to pop some elements, then you can say stack dot pop. So again I say stack dot pop. So how many times? 2 times. So till 5 times it will be true, true, true. Yeah. See. 1, 2, 3, 4, 5. 5 times it will be true, then it will be false. This is for popping and this is for pushing. Your push is nothing but you are adding elements. So I say push elements into stack. Then here I say pop elements from stack. Pop elements from a stack. True, true, true. 5 times you pop it, then 6th time when you try to do it, it's already empty. So you got nothing to pop. And I would like to display before I pop. But how do I display? I don't have any display method in the stack class. So here I am writing it I is 0 and I less than, observe this part, stack dot get array dot length on I plus plus. But understand, do you go till the length or do you go till the top? You need to go till the top because top is the one which guarantees how many elements are there. So you don't need to travel till the length because you may have 5 elements or you may not have 5 elements. But who is keeping track of the number of elements? The top variable. So I go till less than equal to top. Then I try to print, what is that? You got here stack dot get array of I, because I is the one which will tell you the position. Here you see the elements 34, 43, whatever, 34, 43, 45, 54, 67. And after that you try to store 76, 77, 78, which doesn't get into it. Then you keep popping the elements. Alright. So any question on this program, or is it clear? Alright. Then let me quickly finish up the other one too. I would like to develop a data structure called Q. Then I pick the piece of code from the stack class. Just give me a minute. So I just replace, but Q is something different. Okay, the implementation will be different for Q. Then here I go, instead of top I call it as a rate because that is what the terminology says. You can still continue with the top, but normally when you look at the tutorials or when you look at the reading stuff on the internet, for Q they always use a variable called rare. So, and they don't call operation as a push, they call it as a insert, and they don't call it as a pop, they call it as a remove. And understand, the insert operation is same for Q as well as stack. The insert operation is same for Q as well as stack. The insert operation is same for Q as well as stack. So other than changing the variable name, there is no change in the logic. It's same. But when it comes to remove, yes, there is a change, because you won't be removing the last element. In the stack, what did you try to remove? You try to remove the last element. You try to remove the last element. Whereas in the queue, you won't be removing the last element, you are expected to remove the first element. Now I tell you the concerns if I try to remove the first element. In the stack, what I was trying to remove was the last element. Suppose our array was of what size? 5 elements. Our array was of what size? The 5 element. Right. And what I try to do, this is what my first element, this is what my second element, third element, fourth element, and the fifth element. So I have some data over here which was 65. I have some data 55, 77, 78. That's it. Now, what was my top here? What is the value in the top at this position? The top value was, it was 0, 1, 2, 3. My top was 3 because it starts with -1, so it changes to 0, changes to, when I enter 65, the top value is 0. When I enter 55, the top value is 1. When I enter 77, the top value is 2. When I enter 78, the top value is 3. Now in case if I want to delete some element, what happens? I won't be doing much. I just say top minus minus, and when you say top minus minus, what happens? If I want to delete something, I will be saying top minus minus, and that makes it as what? That makes it as what when you do top minus minus? Yes, the top value changes to 2. That's it. So you are not exactly removing the element here. You just decremented your top, and that indicates that you have only 3 elements. You don't have 4 elements there. And this is what happens in stack. This is what happens in stack. You just decrement the top value, that will be taken care of. We assume that the last value is deleted. Whereas in the queue, this is not the same scenario. In the queue, if I say top minus minus, that makes the top as a 2, but that doesn't mean that the value got deleted. Because in the queue, I need to remove what? The first element, not the last element. Then in the queue, what I'm supposed to do is, the 55 will be replaced by 65. Sorry, 65 is replaced with 55, right? And here it will be replaced with 77. What is happening? They are moving one position further. If it is a queue, and top minus minus. So when it comes to queue, if you decrease the rear by, when it comes to queue, you simply say, of course, what was the rear value now? Rear value was 3, and if you simply say rear minus minus, that makes the rear value to changes to 2. But that doesn't mean that deletion happened. If it is a stack, yes, the deletion happened. But if it is a queue, the deletion don't happen with this logic. You need to rearrange the elements. You need to forward you need to replace the 0 position with first position value with second position value with third position value, and after finishing off replacing, then you need to decrement the rear value. So the logic to delete an element in queue is not the same. So first thing what I am supposed to do is, I need to start with 0, and I need to go till what? I need to go till less than equal to rear, and on I++, then what I do here, in the array, into the 0 position, you put the value of what? First position. And once you, 0 position, you put the value of what? First position. And into the first position, you put the value of 2. I think then you don't need to travel till less than equal to rear, you just need to travel till less than r. And once you complete all this process, but you will be performing this process when you have some elements. If your rear is -1, then what will you return? You return false because it's already empty. If the rear is not -1, then you do all this kind of stuff. Then after this again you decrement the counter. This is what happens in the queue. Then let's quickly write a program to run it. Run the queue. So just pick up the piece of code from right. Then I create an object for a queue class. Then using the queue object, I keep calling insert. So I'm adding more than the size. So let's see what happens. Oh, I'm not, you writing a CISO, right? True, 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 and then false. Now let's try to print the elements. Let me copy this part now. So it's not get top, it's gets rare, and it's queue. See, 233246. Now, but let's try to remove it. Removing. Then again I give a CISO. Then I say q dot remove. Now again I try to print it. So let's see what got removed. See here, 233246, because 23 is the first entry. When I say removing, it was a true, but then from where I am accessing the elements, 3246. So 23 got removed. If it is a stack, it's quite opposite. If it is a stack, 6 gets removed, but since it is a queue, 23 got removed. In queue, the first element gets removed. But when I add, where it gets added? Now I try to add it again. Q dot insert 35. Let's see where it gets added. Oh, again adding, after adding again I need to print it to see. When I say added, it's true. Then if you see, it got added as the last element. So it got added as the last element, but it gets removed as the first element. The first element gets removed and the last element gets added as the last element. So that is the queue data structure. Yeah. So any questions on what I did so far, or is it good? Right. So I developed a stack and a queue using what? Using arrays. You can also develop a stack and a queue using linked list. You can also develop a stack and a queue using linked list. So I won't be discussing how do we develop stack and a queue using linked list, but I will be discussing how do we develop a linked list. So to develop a linked list, as I discussed earlier, we need a node first. So I'm creating a class called node because you might have seen there was a different data structure which was holding the data and which was also holding the address of the next node. So I'm creating a data type called node. I'm creating a data type called node which consists of two parts, the data part and the next part. The data part and the next part, and I'm having a get method as well as set method too. Now what next? Let me develop a class linked list. Now in this linked list, I would like to have methods called add first. Now understand this linked list, there is no restriction on the size. They can accommodate as many elements as you want. So I'm adding, why don't you add it as a first? Then why don't you add it as a last? So I can add anywhere. I can add from the first, I can add from the last. Then there is one more interesting one. Add a node and where? Add it at a position I specified. So if you see, I specified a position. So that's the reason I have a return type. I'll let you know why I'm not using a return type. Why I'm not using a return type for add first and add last. Right? Hey, can you excuse me for a couple minutes? I'm sorry. All right. Okay. So when I was defining the add first and add last, my return type was void. Because why the return type is void? Because the linked list is what? It's dynamic in size. So there is no restriction on number of elements I add. So whichever you pass, I keep adding it. So I can add it in the beginning, so I don't need to confirm anything back that I added it, because I'm sure I'm going to add it. See, if you look at the stack and the queue, when you want to add an element, you have to confirm it back whether it's pushed or not, if it is inserted or not, because there was a restriction on the size. So in case if you are not allowing, you have to tell him back that, okay, I didn't allow the element. Whereas in the linked list, you don't need to worry about the false case because it's dynamic in size. You can add as many elements as you want. So you don't need to confirm it back that it is added because it is assumed that it gets added. Then why do I need a Boolean return type for this one, add method? Because here this guy says position. I have 5 elements. If you say add it at a 10th position, that is not possible, right? If I have 5 elements and he says add a new element at the 10th position, that doesn't make sense. That's the reason I'm using this Boolean variable to confirm him that, okay, whether the element is added or not. You got to add first, you got to add last, you got to add. Now here we go. What next? You got add first, you got add last. Now what we do here on the add first and what we do on the add last. So how do we do this? Right? So what I do is I am holding the address of first element. I'll let you know. Let's go back to the pane and let's clear the window. Look at this. Now assume that, as I told you, there will be a node which consists of two parts. You got one console. So imagine you have already these many elements. You already have these many elements. The first element keeps the address of the second keeps the address of the third keeps the address of the fourth, and fourth being a last got no address. But do you gonna label each and every element? No. You're gonna have the address of only the first element. You're only gonna have the address of the first element. The first element address, if you know, then you know that you can find the address of the second element, and with the help of second element you can find the address of the third and fourth and the last. So that's the reason I'm just declaring a pointer called first, which I'm assuming that it's gonna hold the address of the first element. So guys, understand here you have 4 elements, but there is a possibility that there is no element also. So when you want to add something, there are 2 cases here. Alright. When I want to add elements may exist or may not exist. Right. Elements may exist or may not. So when I say exist, when I say may exist, if the elements exist, implies your first key is not null. If element exists, first is not null. If elements not exist, hey, if the element exists, first is not null. If the elements not exist, first is null. So how do I confirm whether elements are there or not? Simple. If your first is null, then there are no elements. When there are no elements, whatever you are trying to add is the first element. So your node becomes the first element. If it is null means what? If the first is null means there are no elements in it. If there are no elements, what are you trying to add is the first element. So if your null is first, you say first equal to node. If the first is not null, If the first is not null, that is, I already have some elements and I want to add a new element. And I want to add what? New element. But where I want to add this new element? I want to add it in the beginning. I want to add it in the beginning. How do I do that? It's very simple. Alright, you got your node. Your node got data and next. In the node next, you keep the address of the first. If you have already many elements, in the node next, keep the address of the first. I did the same. In the node next, I kept the address of the first. But what next? Which should be called as first? Here the second element is referred as first. So there should be one more statement. What is that one more statement is? Rewrite the value of the first. In the first, you are holding the address of the second element. But what did you do? Just override the value and you get the name here. Excuse. See, that's what happened. It's done. Now what is happening? You got the address of the first element. Right? So your add first is over. But how do you add a last element? Because you got the address of the first element, right? You don't have the address of the last element. But how will you add it? How will you add it? Next comes in the add last. In add last also there are two scenarios. It can be empty or it cannot be empty. So again I check, is the list empty or not? If the list is empty, then whatever I am adding is the first and the last element. Understand? If there is no elements in this list, if there are no elements, whatever you are trying to add, that is the last element, right? And that will be the first element too. So you can simply say the node address, you keep it into the first. That solves the problem. But what the other one? If it is not empty, then the challenge starts. If it is not empty, what are you going to do? You cannot store it in the beginning. You have to store here. You have to keep somewhere over here. You have to keep somewhere over here. But do you know what is this element called as? Do you know what is this element called as? We don't know. We only know the address of the first element. Then what I do is, I am giving an alias name to the first. Let's understand, this is important. I am calling the first also as the last. Now this is your last, this is your node, and you want to add it at the end, and this is your first. Then what I am doing when it is not empty, then I am giving an alias name to the first. What is the alias name to the first? I am giving the alias name as the last. Then what I do is, I try to check whether this is the last element or not. How will I check? Last dot get next is not null. But is it not null? What is the next? This is the first element is also called as the last. But what is the next of it? Is it null or not null? No, it is not null. It is holding the address of the second element. So, since it is not null, then what I am going to do is, I am going to change the last value. Now look, what is the statement here? Last equal to last dot get next. That is, since this last dot get next is not null, my last changes. Now this becomes my last. Now understand, I am in a loop. Again I check. Is this get next null? No, it is pointing to third element. Now who becomes my last? Last equal to last dot get next. This becomes my last. Again a loop, last dot get next. Oh, it is not null. Then again what I do? Last equal to last dot get next. Last dot get next, not null. Last equal to last. Last dot get, okay. Yes, right. And you reach here. And in this process, with the help of that loop, you will be reaching this element. Now what is your last dot get next? It is null. So what happens? It is null, so you don't enter the loop. You don't enter the loop. Now into the last next, you keep the address of the new element. That's it. Done. Last dot set next. In the last get next was null. Now what are you doing now? You are replacing this null value with the address of the next element. You added the element at the last. So this is how you added the element at the last. You added the first element, you added the last element. But how do I add element in the middle? How do I add element in the middle? Now here there are a lot of scenarios we need to consider. The first thing is if it is empty. Other one is if it is non-empty. Or if it is not empty, what you're going to do? If it is empty, what you're going to do? So first let's address if it is empty. If the list is empty, if the list is empty, then how are you going to do it? Simple. Oh, you won't be doing directly. You need to check the position. If the list is empty and the position he given you is 1, the list is empty and the position he gave you is 1, then you can add it. So it says first position and it is empty, you can do this. The list is empty and he says 10th position. The list is empty and he says first position, you can add it. But the list is empty and he says some third position, fourth position. When the list is empty, and how can he say about the third position and fourth position? Then I say, hey, you cannot add it here. The list is empty and the position is 1, you can add it. So I did it. So what I did so far is, it is for empty. When it is empty, you can add it at the position 1, but you cannot add it at any other position. So I return false. If it is position 1, I am adding it. Now next scenario. The next scenario is list is not empty. The next scenario is list is not empty. The next scenario is list is not empty, but the position is 1. The list is not empty, but the position is 1. What you can do happily, you don't need to write any logic. You can simply say add first. You already have a method, right? You already have a add first method. He said add it at the first position. Then why should I write the logic again here? If the position is 1 and the list is not empty, you can simply call it. Right? You can do that. Otherwise, we can write it in a better way. First, we can directly check the position. If the okay, yeah, no. I think what we did was better one. I think so. Yeah, because we need to return a value. I think this is what we did was a better one. If the position is 1, call add first, then return true. So non-empty and position is 1. Now next thing. What is the next thing is? It is non-empty and we need to figure out the length of the list now. We need to find the length of the list now. Now here I say position is not 1. Position is 1, you add it. If the position is not 1, then what you do? So what I try to do is I try to quickly find out the length of the. How do I find the length? Again I use this logic. Travel from first to last, and between this process try to find the length. So once you complete this loop, you have the length. Now once you have the length, then you can see here what you want to do. If the position is length plus 1, that is, you want to add it as the last element. If the position is 1, position is not 1. If the position is not 1, is that position equal to the length plus 1? If it is length plus 1, you want to add it as a last. Just call add last. If the position is not length plus 1, if the position is, oh here you need to do 2. If the position is less than length, if the position is less than length, here also. If the position is length plus 1, yeah. If the position is length plus 1, you do that. If the position is, so if the position is length plus 1, you add it as a last. If the position is length less than length plus 1, then what you need to do? And again you need to write some logic. That we will do that later. What is the third scenario? The third scenario is position is greater than length plus 1. Position is greater than length plus 1. When the position is greater than length plus 1, you cannot add it. So I say false. Because position need to be length plus 1, or it is less than length plus 1, but it cannot be greater than, because my length is 5 and I can add it as a 6th element, but I cannot add it as a 7th element. So if your position is greater than the length plus 1, then you go it as a false. Now when your position is less than length plus 1, suppose you have 5 elements and you want to reach third position. You have 5 elements and you want to reach third position. How do you add it? Again you need to write a loop. So it is completely a logical thinking, it takes a bit of time, right? So what I try to do is, I'm trying to find out the position here. Temp. I'm trying to count. So what I am trying to do here is, I am trying to count the position. So if the count plus 1 is equal to the position, then I reach the element. As I said, I have 5 elements. and I want to insert a third position, then this is what I'm doing. I'm repeating the loop, incrementing the count. If the count equal to position, then I won't be continuing it. I'll just break it. Right? I just break the loop. And after breaking the loop, then I have a possibility. Guys, here. Now this is my first element, second element, third element, fourth element, fifth element, sixth element. Doesn't it have to be less than the length plus 1, greater than? Yeah, true. Minus 1 also we need to consider. Right? We also need to check because the position cannot be lesser. So we can also check that, or we can also, before we get into all this stuff, we can simply check over here, because I don't need to do all this kind of stuff. If my position is less than 1, because I cannot add it in a 0, I cannot add it in minus 1. So if anything is less than minus 1, I can ignore, I can simply return false. Guys, what exactly I'm trying to do now is, I want to add, this is 1, 2, 3, 4, 5, 6. So I want to add it as a third element. If I want to add it as a third element, I know this is where I need to add it. But how do I reach here? So same, as usual, you give a alias name to the first, call it as a temp. Temp dot get next not null, increment the count, count changes to 1, then temp equal to temp plus 1. Then your temp again moves here. Count is 1, temp goes here. Then again temp dot get next not null. Alright, and count is 2. So where exactly I need to add? Third position. So I'm at the right position here. That's what I'm happening here, right? Time dot get next not null, increment the count, check whether the count plus 1 is position or not. Yes, when temp dot get next not null, count is 2, 2 plus 1 is 3, I'm in the right position. Then what I do here is, this is your temp. Now what I need to do? The new node should become the third element, right? The new node should become the third element. Then what? The temp should point to the node and node should point to this fourth element. Whatever the element the temp is pointing to, that should be pointed by node and temp should be pointing to node. Here you need to play things very carefully. I will make, if you see, observe here, I make the node next point to what? Temp next. Now what is the statement indicates? The temp next was pointing to something, but now that is pointed by node next. That is, I make the node next point to this. Now after this, my temp next will be pointing to the node. Now instead of pointing here, the temp next was pointing to this earlier. Now I got rid of this. Now I make this, got the element in the middle. Right. I'm done with the task. So I successfully, okay, I have some other challenges here. Return true, return false, then here. just add. Then let's have the main method to this to test. But before I have a main method, let me have a getter method to the variable first. Class run linker list, and you got a main method. You can say whatever you want to see. 34 is add first. Oh, you cannot add like this, because what is this linked list accepting? It is accepting a node. So you should create a node first. Then I define a constructor in the node class. It takes an integer argument. Thirty-four, 4, 3, 5, 6. Right. So let's first test this one. Then we can go. I would like to print it. How will I print it? This is important. Let me take node temp equal to ll dot get first. I'm getting the address and storing into temp. If it is not null, then I have elements. Then I try to print the data of it. And after printing the data, then I say move to the next element. So that's what happened here. First I print the data of this, then I move to the next. Print the data, move to the next. Print the data, move to the next. Three, 4, 34, then 5, 6. Why? 34 is first. Then again you said add first. Then 4 got added. Again you said add first. Then 3 got added. So that's the reason you see 3, 4, 34. Then you say add last 5, add last 6. Now what I'm left with? What I need to test? I have to test the add, right? So I'll be adding new node, let's say 56. Watch position. I want to add a third position. Let's see. Oh, it's not getting added. Oh, where did I? Oh, I'm adding it as a last, right? But it should at least get added as a last element. Oh, okay. No. This is fine. 56. That should be at a third position. That is 3, 4, 34. So it's not getting added in the third position. So let's quickly debug this. What happened? 56 and a third position. So let's go here into the add mid. Position less than 1. Oh, I'm sorry. Here I need to say, right? Position greater than 1 or greater than equal to 1. Then I'll be adding it. Position is greater than 1, I'll be adding it. If it is anything less than, I'll be returning false. That was a mistake. Hopefully that was a mistake. Yeah, got it. Third position, right? This is 1, this is 2, this is 3. You add in the middle. We can also test the other one. So we already have 1, 2, 3, 4, 5, 6 elements. Then I can also say 7th position. New node, let it be 65, then a position 7. It's not accommodating. Yeah, it's not accommodating the 7th position. 1, 2, 3, 4, 5, 6, 7. So if position greater than 1 and it is not empty, position 1 no, then we are trying to find the position was 7, length was 6. Yeah, 6 plus 1 is 7, right? It should allow it. What exactly happening here? We got a 1, 2, 3, 4, 5, 6. We got 6 elements and I want to add it at the 7th position. Then it should have allowed it. Position equal to length plus 1. Then position was 7, the length plus 1 is happening. Okay. Let's try to find the length. So why 4 was the length and 5 was the length? Okay, we added, right? Okay, fine. There were 2 elements. 2 times we said add, make. Okay, here, position. 1, 2, 3, 4, 5. Yeah. The size was 5. 1, 2, 3, 4, 5. It should be 5 and the 6. That's the problem. Length to list. Length is 0. Length plus plus. It changes to 1. There is something wrong here. The length is 0. Last dot get next is not null, then length plus plus. Alright, I'll leave it to you people as an assignment. Right? Try to figure it out. What was the problem? There is something wrong with the length only because I have 6 elements. If you observe, there is 1, 2, 3, 4, 5. So when I'm adding this, the size should be 6. When I'm adding this, the size should be 5. When I'm adding this, the size should be 6, but it is showing one number less. Please try to figure it out. And one more thing is, there were a few more methods I would like to add to this. There should be a public void delete first, but the return type won't be first. Rather, you should have a return type as a node. You should return the node which is deleted. Similarly, here we go. Delete last and delete. Delete last. And when you say delete, you will be specifying the position. Which element need to be deleted. So do fill the logics for these 3 methods and also try to debug what is the problem with the add method. Right? Only one scenario is problem. The first scenario is working. That is, if it is not empty and the position is 1, it works. If it is not empty and the position is middle, it works. If the position is greater than the length, then there is a problem. Please try to figure it out what exactly the problem was. The problem was in finding the length only. So just focus and try to figure it out what exactly is going wrong. So any questions on this? Yeah. Okay, length is starting from 0, last dot get next null. So okay, fine. But okay, right, perfect. Okay, okay. So I okay, got it. Thank you. If I want to do length is 0, then you should not say last dot get next. This is how you should get started. Now you will get it, I think. Yeah, you have it. Okay. So the thing is, uh, I was doing this kind of program, and there is no need of doing this. There is no need to write our own program for linked list. There is no need to write our own program for stack. There is no need to write our own program for queue. I'm writing a queue program. I developed a queue, I developed a stack, and I developed a linked list. But actually there is no need of doing this. We already have some built-in API called java.util. We already have a built-in API called java.util. Here we go, Java SE6 API. Then click on this. Then you see the stuff. The leftmost corner, the top and the leftmost corner will give you the package names. Go down, click on the java.util. Then the bottom left corner, you will see the list of the classes and interfaces. Then if you observe here, you will see a lot of things. You see linked list, you see stack, you see queue, you see a stack, you see a queue. There are a lot of things over here. So the reason or the intention in discussing these programs is when you want to understand or when you want to figure out what is the difference between a stack and the queue, and what is the difference between the array implementation of the stack and array implementation of the queue, and there are a lot of other things like map, set, right? And so if you want to understand those concepts well, I want you guys to make an attempt to implement these classes on your own. Even linked list program, there are few blocks which I left it for you. Try to complete them and try to implement the stack and the queue using linked list. Now I implemented the stack and the queue using arrays. I discussed linked list. Try to implement the stack and the queue using linked list. Then try to differentiate what was the advantage of using linked list and what was the advantage of stack and queue, right? So you need to figure it out, the performance, and you also need to figure it out the logic, the number of lines of code you are taking to read the element, or the number of iterations you did to delete an element. So these all stuff you need, if you can try to understand, then the purpose of learning collection framework will be fruitful, because most of the interview based questions will not be like what is stack and what is queue or what is list. The interview point of questions will be based on how exactly which one is efficient than the another, right? And why we need to use this, and which scenario you apply a stack and which scenario you apply a queue, or where you go for linked list and when you go for array. These kind of questions will be the interview questions. So in order to understand this concept better, I want you guys to do this implementations. Yeah, I think I was late a bit today, and I'm sorry for that, and I'm sure that I'll be on time for the next session. Right. So any questions for me before I wind up for today? Okay. So if all good, then we'll stop here. We'll continue the next session. That will be again on Monday evening, right? And as usual, I forward the course, whatever the programs we did, and Shiva is sharing you the recordings, I feel. Thank you.